All right, so we're good. Let's make sure we're live. All right. What's good, everybody? Welcome to our live stream today. Today, what we're going to focus on is solving equations. So, we're going to look at about 6 different problems. When we talk about our live stream, guys, what's so special about our live stream is that we take the time to go over the problems compared to our regular videos. And we're going to do a little bit more explaining so that you guys master these topics. Really hope you like this video. So when we talk about solving equations, guys, there's literally 3 steps that I break this down into. Number 1 is distribute if necessary. 2 is simplify each side of the equation, and then 3 is solve. So when we look at this first example, we just need to see what's going on with the problem. So I noticed that we're going to distribute here, and we're also going to distribute here, and that this is negative. So let's always look at the problem to see what's going on and to make your first best step. So we're going to distribute 2 different times. So once we distribute, we'll have 10x plus 6 minus 28x minus 4 is equal to negative 88. So step 1, we distributed. Now what we need to do is simplify by combining like terms. And something that I want to tell you guys, or a trick, is this. So let's say we have, and let's just switch colors so this sticks out. So we have 2 like terms, right? We have positive 6, negative 4. We know eventually we're going to move those constants and combine it with this constant on the other side. Now, what I see students do, and I think is the wrong step, is that they will go ahead, add 4, right? Because this is negative, and then subtract 6. And that is right. But typically, when you're solving equations, we could definitely make a mistake. So before we move anything from one side to the other, let's clean it up on the same side. So when I combine a positive 10x and a negative 28x, I'm going to get negative 18x plus 2 is equal to negative 88. So that second step of simplifying, always clean up each side of the equation first before we try to move things over, because it's going to limit the amount of steps, and it's going to limit us moving more than one term to the other side. We don't want to do that step more than once because we're bound to make a mistake, right? We're human. So now I combine my like terms one time, right? We'll just do this one time instead of twice. I have negative 18x is equal to negative 90. Now, just remember our signs, right? We simplify both sides. Now we're going to solve. And when we solve, we know when we divide a negative by a negative, we should get a positive. So just be mindful of your signs too, because I know I make a mistake with that. So now we divide, and we're going to have x is equal to negative 90 divided by 18. And let's just make sure we get the right answer, which is going to be positive 5 as an answer. So when we're thinking about solving multi-step equations, guys, 3 steps I'll talk about: distribute if necessary, simplify, and then solve. So now what we're going to do is go on to our next question. All right, let's get it. All right. So problem number 2, now we're looking, and we're starting this 3-step process all over again. So when I'm looking at my equation, I'm noticing, hey, I'm going to need to distribute. Okay. So we know we're going to have to distribute here 7 times x, 7 times negative 5. So we'll have 7x minus 35. All right. Remember that when we distribute, we only distribute to what's inside the parentheses. So I multiply 7 by x and 5. 3 is outside the parentheses. Nothing happens with it. It stays the same. So we just bring it down. And then on the other side, we're going to go ahead again and distribute. So this is why it's just important that with the first step, just look at the problem, analyze it. What is it asking us to do? In our first step, we know that we need to distribute here with 7 and x minus 5, and distribute here with 10x and, I'm 10, I'm sorry, and x plus 1. So once we do that, we're going to have 10x plus 10, and then now we're done with the distributing aspect. Now we could combine our like terms on the same side of the equation. Then we could move things from one side to the other. So here goes my like terms, right? We have 10x minus 35 is equal to 10x plus 10. At this stage, guys, your eyebrow should always raise anytime you see the variable or a constant that is the exact same, because something special is going to happen here, and I know this throws students off. So let's say at this step we combine our x's. Subtract 10x here, subtract 10x here. We have negative 35 is equal to just positive 10, right? Because our variables canceled out. So what does this mean when we get here and there's no variable, but we have two constants? One is saying that negative 35 is equal to 10. That is not true. So this is what we talk about when we say a equation that has no solution. When we look at this problem, this equation is not equal at all. Negative 35 will never be equal to negative 11. Now let's say you are one of those students. Let's rewrite this step here. So we have 10x minus 35 is equal to 10x plus 10. So let's say we didn't do that, right? Let's say we combined our constants first before we combined our variables. So with this step here, I'm going to add 35 to each side, right? And then we're going to bring this up here. So what we would have would be 10x is equal to 10x plus 45, right? Because we know solving equations is more than one way to solve, and everyone may not get to this step and understand, hey, this is no solution. So when we do it this way now, right, I'm going to combine my x's, and always remember, your variable needs to be on one side of the equation, and the numbers with no variable need to be on the opposite side of the equation. And when we talk about opposite side, we're talking about the opposite side of the equal sign. So when I subtract 10x, right, another way we could get to the same answer is now 0 is equal to 45. There will never be a case where 0 is equal to 45. So if you have an equation where the variables cancel out, or we get to the end and we have two numbers that are not equal to each other, that means that there is no solution. There is no number that's going to make this a true statement, meaning that the left-hand side of the equation is equal to the right-hand side, or the right-hand side is equal to the left-hand side. Same thing. So please be mindful of that, because you're going to see a lot of no solution problems, and you have to understand what no solution means, okay? All right. And if you guys have any questions, always just type it in the chat box. We're always trying to monitor and make sure we address any issues for you guys. But thank you so much for joining us today on our live stream. Really hope you're enjoying this lesson. If you are, smash the like button for your boy. All right, so this is going to be the next problem that we're going to take care of when we're talking about solving multi-step equations. All right, so problem number 3 now, right? We're looking at this problem. We want to analyze to see if we need to distribute. What is going to be our first step? So I notice here on this left side, I'm going to distribute and multiply negative 5 by x and by 2. So once I distribute, I have negative 5x minus 10 is equal to. Just don't forget the negative sign and how it changes the value, meaning whether the product is going to be positive or is going to be negative. Now, when we go on this side, they used to get me when I was in algebra. I would look real quick, and because I just distributed on the left side, I'll say, okay, I'm going to multiply 13 by x and 1, but whoa, that's not true. What they like to do is give us the illusion, play a trick on us, and make us think we're going to distribute. And we are, but it's not going to be 13. It's going to be this negative sign. So what happens here is 13 stays the same, and this negative sign is basically going to change the signs of the terms inside of the parentheses. So now instead of positive x, we're going to have negative x, and instead of -1, we're going to have +1. So we distributed. Now we need to simplify each side of my equation. So left-hand side is simplified, -5x minus 10. These aren't like terms, nothing we could do with it. Go on this side, we have -x plus 14, right? Now all we need to do now is start simplifying by moving things from one side to the other. So I'm going to move my x over to the left side. We're going to do the opposite of subtracting x, right? This is negative, so we add. Same thing here. We have -4x minus 10 is equal to 14. Now, once we combine by adding 10, and as we just stop at this process here, guys, remember the importance of why we're moving things from one side to the other. One, yes, variable has to be on the one side of the equation, the equal sign, I'm sorry. The numbers with no variable, the constants have to be on the opposite side. But remember, a very important rule is the balancing of an equation, meaning what we do on one side, we have to do to the other. And this is what I mean. So if I'm going to add x to itself on this side, I have to make sure on the opposite side of the equation, I add x to its like term. And then when we get down to this step right here, you see that I've added 10 to itself on the left side. And to balance the equation so that we get the problem right, I have to also add that 10 on the right side. If I don't add it on the right side, the equation is not balanced. And instead of having -4x is equal to 24, we would have -4x is equal to 14. And our entire problem is going to be wrong. So please understand what we mean by balancing the equations. In the second half of the video, I'm going to point that out a little bit more. So now we divide, and I know everybody knows the answer. We're going to get x is equal to -6. So solving equations, guys, multi-step equations, equations with variables on both sides, these three steps are going to help, right? We're going to analyze, right, and determine if we need to distribute or not. We're going to simplify each side by combining like terms. And at the end, we're going to solve by getting the variables on one side and constants on the other. Now, the second part of this video, we're going to be talking about algebraic proportions. So I'm going to teach you guys how to set it up. And then once we set it up, it's going to help us with solving equations. So let's look at the very first instance, right? So we have 6 over 4 is equal to x over 2. And when we're talking about proportions, guys, we're looking for these two fractions to be the same. So when I divide the top number by the bottom number, I should get the same exact decimal. And the way that we solve proportions is that we're going to cross multiply, right? So that's that cross products. So we draw an x. After we draw x, we're going to set up an equation. 4 times x is equal to 6 times 2. Now I have 4x is equal to 12, right? And now we're going to solve. So remember, when we talk about balancing the equation, if I divide one side by 4, now I got to go on the opposite side of the equal sign and do that same step. Divide by 4, and we're going to get x is equal to 3. And once we look at this, right, let's say we erase this. If we multiply both the top and the bottom by 2, we would have the same fraction, meaning 3 times 2 gives us 6, 2 times 2 gives us 4. We would know that these are equivalent fractions. They have the same number value. Now, in problem number 2, they try to make proportions complicated or tricky by giving you a binomial, okay? So this is what I mean. Let's write this problem down. So we have 2 divided by 10 is equal to 4 over x plus 5. All right, sorry. Couldn't read my own handwriting for a second. So when we get into polynomials, which you guys will get into now algebra, it's basically just an expression, right? So a expression, and it could be x, 2x, and so forth. I'm not going to get into that too now. But anytime you have two terms like this is called a binomial. So when you have two terms, guys, put parentheses around it because we're going to distribute. So when we talk about proportions, that first step, we draw our x so we know what we're multiplying with each other. So I have 10 times 4 is equal to 2 times x plus 5. Now, this is the trick with proportions when we have a binomial like we do right here. We're still going to cross multiply, we're still going to set up an equation, and we're still going to solve. Only difference now is that when we set this up, we're distributing, meaning we're going to multiply 2 by x to get 2x and 2 by 5 to get 10. And then on the other side, we simplify to get 40. So at this step now, guys, it turns into a regular equation. And when we're balancing this equation, I want to subtract 10 from itself, right? That's gone. And then on the opposite side of the equal sign, I have to do the same thing so that the equation's balanced. So I subtract 10. Now we have 30 is equal to 2x. And once I divide by 2, right, go on the other side as well, divide by 2, we're going to get 15 is equal to x. Or if you like it the other way like I do, x is equal to 15. This is the same exact answer. All right? Okay. All right. All right, so that's our first two problems, guys. And when we're talking about proportions, we're going to look at another problem too, because I want to explain this type of problem as well. So our next example is this. We have 2x minus 6 divided by x plus 4 is equal to 3 over 5. So like I said, now we have two binomials, right? Have a binomial here, one term, second term, and we have a binomial here. Here's our first term, 2x. Here's our second term, negative 6. So when we have a binomial with these polynomials, right, we know what we're going to do. We're going to distribute. So let's set up our x for cross multiplication. I'm going to multiply 5 by 2x minus 6, and that is equal to 3 times x plus 4. If you have it the other way around, you're going to get the same answer. Meaning, if you had 3 times x plus 4 is equal to, and then 5 times 2x minus 6, it's the same exact thing. We would get the same exact answer. So now we're looking and we say, hey, we have to distribute, right? Both of my terms are positive. So I know once I multiply, my products are going to be positive apart from when I multiply 5 and negative 6. So we're going to get 10x minus 30 is equal to 3x plus 12. Okay? So in this step, I'm going to switch back to black, let it stick out some. And let me ask you guys a question, right? Comment down below. When you're combining your like terms in a situation like this, what is the most complicated part that you trip on or that you just make a mistake or you get confused with? Comment down below. We want to make sure that we address that for you. Me, I always like my variables on the left hand side. That's just how I am. So we're going to subtract 3x first. Balancing the equation, if I subtract 3x on this side of the equal sign, I got to do it on the other side. So we subtract 3x. 7x minus 30 is equal to 12. Nothing happened with these two because we didn't combine them yet. And we know that 3x is not like terms with negative 30 or 12. So now at this step, we have to, let me repeat this. We have to have the variable on and the constant on the opposite sides of the equal sign. If you subtracted 12 and brought it over onto the left-hand side, we would have our problem incorrect, okay? We could not be able to solve. And I'm going to show you that. So once we add 30, right, we'll get 7x is equal to 42. We're going to divide by 7 on the left side. So that means we also have to divide on the right side by 7. We have x is equal to positive 6. Now, before I go on to the very last problem of the day, let's take this step here and let's see what happens if we did the incorrect step. So we have 7x minus 30 is equal to 12. Now, what I've seen in let's see, over a decade of teaching math from the K through 12 K through 12 levels, this is what I'll see a lot of times. Students will do the right steps but make an error by having the variable and the constant on the same side. Please just make sure you don't rush, because that's all it is, rushing. So they subtract 12. Subtract 12. Now they'll say 7x is equal to negative 42, right? I'll see something like that, or they'll just have 7x minus 42 is equal to 0, and then they'll just say 7x is equal to 42. So sometimes they'll get the right answer if they did it like this, meaning they re-added it back over. But that's extra steps. We don't want to take extra steps because we can make a simple mistake. And up here in the first example, once we divide, that negative sign, because it's on the wrong side of the equal sign, we're going to get x is equal to negative 6 instead of positive 6. So just please be mindful of that when you guys are solving, okay? And then we see someone jumped in. Really appreciate your comment. Good afternoon back to you too. Hopefully you've been here for most of the show because we're about to jump onto our last problem of the day. But we're glad that you joined us. And just know that when we're done with our live stream, they're typically going to be uploaded right after. So you'll be able to go back, replay this video at any time that you want. All right, so our last problem of the day, where is it? Okay, let's set this one up. Okay, so the last problem I really wanted to talk about, and what they typically will not do, is give us more than one x. I did a problem like this in one of our SAT videos, but I wanted to make sure that I showed it with you guys as well. So even when they have more than one x, guys, the rules, the steps are still the same. This is just them trying to trick you, okay? So first thing we know, we have a binomial, right? So what did I say? Or not what did I say? What was the recommendation? Put parentheses around it. Now we draw our x, and now we set up our equation. So I know 2 times x is going to be equal to 5 times x minus 3. All right? We know on this left-hand side, this just simplifies to 2x. On the right side, we need to make sure that we distribute. So I'm going to get 5x minus 15. Now, at this step here, the best thing for us to do is to subtract the 5x, right? Moving 5x to the other side, because once we do that, variables on one side of the equal sign, constants are on the opposite side, which is what we need. That's the objective, okay? I think students forget that sometimes. So we subtract 5x, and at this step here, we have negative 3x is equal to negative 15. We know we're going to divide by negative 3. What we do on one side of the equation, we have to do on the other. And then we're going to get x is equal to positive 5. Now, before we wrap this up, we're going to check this thing. We're going to check to see if we did this right. And you could do this as well, not on the test, because you're not going to have enough time, but on your homework. All right, so let's just draw a little squiggly line right here, and we're going to switch back to black. So this is how we would check any of these proportions. So we're going to plug in 5 anywhere we see x. And we're going to simplify and see if we get the same answer, right? So 5 minus 3, okay, over. So I know on this left-hand side, much easier for us to simplify. We're going to have 1 as a final answer. 5 minus 2 gives me 2. This is all over 2. 2 divided by 2 gives me 1. 1 is equal to 1. And there goes the magic. We know we got this problem correct because the left-hand side of the equation equals the right side. And I'm not going to lie, those ones look really, really ugly. But thank you guys for joining us today on our live stream. If you have any questions, comment down below on the video for us. Subscribe to the channel. Leave any comments for future videos you guys would like to see. Or if you had questions on today's video, thank you guys again and join us next time on our live stream.